We want to add and subtract rational expressions. In order to do that, we need to be able to add and subtract with like denominators, find the least common multiple, add and subtract with unlike denominators, and then we're also going to simplify a complex fraction. So in order to add and subtract with like denominators, so in this case, they're the same. Let A, B, and C be expressions with C not equal to 0. Again, the reason C is not equal to 0 is because C is in the denominator, and so we can't divide by the denominator of 0. But if we have C in the denominator of two fractions that we want to add together, we just add the numerator and then leave the denominator as C. If we want to subtract and they have the same denominator, we leave the denominator alone and just subtract the numerators like we see here. If we want to add and subtract with unlike denominators, so then let A, B, and C be expressions with C not equal to 0 and D not equal to 0. Again, C and D can't be 0 because they're in the denominator. So if we're trying to add A divided by C plus B divided by D, we can't add these together because they have to have a common denominator. So what's missing from A divided by C in order to add it? Well, we need to have the D value. So on the left side, we're going to add the D variable. So we multiply by D divided by D. On the right side, what's missing? Over here, we're missing the C value. So on the right side, we're going to multiply by C divided by C. And once we have that, we can just add the numerator AD plus CB, and then leave the denominator alone, which CD. Now notice that these are all equal signs. So these are just different ways of expressing that would be the same value if you substitute it in your calculator. And with subtraction, it's the same thing. We have to have a common denominator. So over here, we're missing the D variable. So we multiply by D divided by D. And over here, we're missing the C variable. So we multiply by C divided by C. And then we get AD minus CB divided by CD. So why are we multiplying by D over D and C over C? Well, really, what this value ends up being is just 1 all the time. So why are we multiplying by 1? So that's what we're doing. We're multiplying by 1, or the multiplicative identity. So that just says anything times 1 is just itself, right? And you can substitute this in your calculator. What's 2 divided by 2? 2 divided by 2 is 1. What is x divided by x? X divided by x is just 1. So we're not changing the value here. We took the fraction, which was b divided by d, and we multiplied by the value of 1. Well, the value of 1 is just itself. So all we're doing, we're not changing the value, we're just changing the way that it looks. So if we look at this example right here, we have 3 multiplied by x divided by x. Well, x divided by x, this whole fraction in the parentheses here, that value is equal to 1. So really we're saying 3 times 1. Well, that's not changing the value, that's just changing the way it looks. So now it says 3 over x divided by x. The value is still the same. The value when we started, when we get all said and done, the value here will be 3. The value when we started here was 3, and the value hasn't changed. The only thing that's changed is the way it looks. And same thing with the last one. We can FOIL that out if we want, but it just ends up being itself. So we just get 3 times x minus 1 squared divided by x minus 1 squared. That value, x minus 1 squared divided by x minus 1 squared. This whole thing right here, this is still equal to just 1.